Two MS is in the ratio of 4:3. So essentially, if that was 4x, that length would be 3x. Is that okay with you guys? Prove that PQM and triangle SNM are similar. I'm not actually going to need the 3x and the 4x just yet. So here's what we're going to do. Angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6, okay? So triangle PQM, triangle, what's the other one? MSN or SNM. Okay, let's go for this. I'm going to say angle 1 equals angle 2, why? Vertically opposite. Make sure you don't write it vertically up. You just got to write the full thing down in your test, okay? Angle 3 equals angle 4, why? Alternates. And finally, angle 5 equals angle 6, why? Third angle or alternate, whichever one you want. Okay, if you're doing this officially, what would you say down the very bottom? All three angles are the same. Therefore, triangles PQM and SNM are similar. Everybody all right so far? Happy now? Okay, great. I'm just going to get rid of all that now, okay, because we don't really need it. Okay, let's get rid of it all. Great. Next one. If PQ is 24, if P to Q is 24, that makes S to R what? 24 as well. Calculate M to S, which is that one there. Okay, what else does it give me? M to N. Where's M to N? This one here, isn't it? I'm going to use a bit of color coding because I find the numbers hard to follow sometimes. So I'm going to do it like this. Find the colors easier to manage. Green angles, yes, they're the same, aren't they? Blue angles are the same. And finally, red ones are the same, yeah? Everybody cool with that? Okay. Now, 24 for 24 there. What does it give me? MN, where's MN? M to N is... Oh God, I'm losing it. M to N is 30. Okay. Right. Now, that doesn't help us much more than that. Anything else? Nope, that's all our information, isn't it? Does it give us anything about Q to R? You have the big triangle and the small triangle. Everybody agree with that? So look at this. See P to M. What two colors is P to M in between? What's P to M in between? The red and the green. What's in between the red and the green on the smaller one? M to S. And we know that ratio is 4:3. We know for every 3 centimeters the smaller triangle has, the bigger triangle will have 4 centimeters. Everybody cool with that? So, see in between the red and the blue. See the red and the blue. See where that's 24. Yeah? So, that's the same as 24 divided by what? 4/3 is the same as 24 divided by what? 18, isn't it? Because you multiply 4 multiplied by 6 gives you 24, so 3 multiplied by 6 gives you 18. Where do you think I'm going to put that 18? Red to blue. There you go. 18 for that. Everybody all right with that? Now, Q to M. Same deal again. MN is the smaller one, isn't it? Would you agree with that? What's MN in between? MN is in between green and blue, 30. That's the smaller triangle. What's the equivalent side on the larger triangle? QM, which would be 40. Because you multiply 3 by 10 to get it to 30. Therefore, you must multiply 4 by 10 to get it to 40. 40 over 30. So Q to M is 40. Everybody all right with that? Who got it out of interest? Okay. It was tricky. Okay, let's move on. 22. Prove they're similar. Right. I think at this stage, like, it gives you angle 1 equals angle 2, doesn't it? Angle 1 equals angle 2 given. Everybody's happy with angle 3 equals angle 4. Why? Vertically opposite. And finally, what about angle 5 equals angle 6? Why? Third angle. Therefore, they are similar. You'd actually write that down in tests. Therefore, PQR and PTS are similar. I think we've done how many of them at this stage? Too many, like you should know it inside out now. All right, calculate ST and P to R. So I'm just going to get rid of all this because that's just the little proof at the start. That's easy. Okay. And I'm just going to color code it again. Do you guys find the colors easier to follow than the numbers? I do anyway, I have to say. So I'll go red, red, blue, blue, green, green. Means they're the same angle, is that right? Now, let's fill out what we have. P to Q is what? P to Q is 6. Q to R, 9. P to T, 12. P to S, 8. There we go. We have two of them that are equivalent. Which ones are equivalent? 8 and 6. How do we know they're equivalent? They're both in between the blue and the red. So large over small is 8 over 6, which is the same as 4 over 3. For every 3 centimeters the small triangle has, the large one will have 4. Okay, it wants ST. ST is equivalent to what? ST is equivalent to what, guys? It's in between blue and green, which will mean 9, yeah? How'd you turn 3 into 9? What you need to turn 4 into then? 12. ST has to equal 12. Is that okay with you guys? Okay. ST is equal to 12. Makes an isosceles triangle, doesn't it? What's P to R then? Because it also has to be an isosceles triangle because they're similar. Is that alright? Done. Let's move on. Who got that one out? That was the easier one. Okay, good job. Now, 23. Big one equals small one, so let's okay, PQR and PMN. Let's call it blue dot here. It's the same as the blue dot down here. P is a common angle, isn't it? Red dot equals red dot. Therefore, the third angle is green dot equals green dot. Is it okay we don't go through the formal proof again? Yes? Yeah. So everybody happy they're both similar? Okay. PM is what, guys? 4. And PN, 5. MQ, 11. But we know PM. PM is 4. What's P to Q? There we go. Okay, we have the large triangle and we have the small triangle. Okay, What two sides are equivalent that we both know? We know the two red to blues, don't we? One of them's 15 and the other one is 5. So what does that mean? Huh? The large triangle is 3 times bigger than the small one. So what can you say P to R is, blue and red, and we want green and red. What can you say P to R is? And we know what P to R is? 3 times bigger than 4? 12. Now, P to R is 12. If P to R is 12, and you know that P to... Wait, I'm confused. Sorry, my brain's still shut down here for a second. Oh, yeah. Red to green is 4. That means the other red to green is 12. That makes that 12. We know P to N is 5, so what does that make N to R? N to R, guys? 7, isn't it? Because 7 plus 5 has to equal 12. So N to R is 7. Is that right? Cool. All right, that's what's done on this exercise.